Okay, welcome back. Let us today concentrate on the what we call Divergent Theorem, and very good day to all of you. I'm going to continue with the what we call as Divergent Theorem, and the Divergent Theorem is one of the powerful theorem in the vector calculus, and we have seen divergent. Okay, we have seen the divergent theory, but this divergent, basically we're going to incorporate that into the Gauss. Okay, we're going to use divergent Gauss theorem. Okay, Gauss, we're going to use divergent Gauss theorem. Okay, Gauss theorem. And okay, and since before earlier we did learn something called divergence, and the divergence is basically the analysis of outflow minus inflow of volume density. Okay, with that, and we learned something called del. The del is basically a del x to the I, del y to the j, del z to the k, and we combine that to the f, whereby f can be f, and the f can be a fi, gj, hk. And since f is a vector, the divergent, basically the definition of the divergent of f will be defined as del dot to the f, or we call it this is a def f. And normally once we del dot product with the f will produce del f to the del x, del g to the del y, plus del h to the del z. Okay, this is what we call as a divergent. Today we're going to focus more detailed theorem called divergent Gauss theorem. This is a definition of the divergent, but I'm going to introduce to you divergent Gauss theorem or divergent theorem. Sometimes they call it that as a Gauss theorem. Okay, with that, before I move into this theorem, the divergent theorem, let me introduce to you few things. Okay, let me introduce to you few things. How to sketch volume. Okay, volume, there are various ways to sketch the volume, and as you all know, I'm going to introduce you roughly, at least you should know for this our syllabus, you should know 4 type of volume. One of the things is cuboid or cube. Basically it can be, how we will sketch this. Okay, the sketching, the definition normally will be x equals to y, x equals to 0, y equals to 0, z equals to 0, and because it's a quadrant or octant base, it will be defined straight away. It's a straight line. Okay, therefore when you start sketching the straight line on this or coordinate system accordingly, then you will get a 1 cubic or cuboid or whatever, but it's all straight line based sketching. The second one is tetrahedron. Okay, it's a kind of triangle base. You can see that the triangle base, and this normally they will give you, for example, the example is a 3x 4y 6z, okay, 12, for example. Okay, and this kind of equation is a kind of still linear equation. You can see that it's a straight line, and x equals to 0, y equals to 0, then z equals to 2. Okay, it's easy. You just substitute x to the 0, y equals to 0, z equals to 2. Okay, here y equals to 0, z equals to 0, then x equals to 4. Similarly, z equals to 0, z equals to 0, x equals to 0, y equals to 3. Then you can you just define according to the x-axis, y-axis. The definition easily can be defined as a 0, 0, 2, and 4, 0, 0, and 0, 3, 0. Okay, this sketch so far you should be able to see. Once you see the equation, you should be able to sketch the volume. This is very important so far. Then let me use the same paper. It's not saving the paper, but I want something that you can immediately refer to for the immediate reference. Okay, number 3. Another kind of sketch that very common is cylindrical. I give you some example in this particular case. This, if you notice that this is circle, of course, and if you can see one more additional thing called z equals to 5, this means there is something called additional things inside. Okay, additional. Therefore, this z, when you sketch for the 3 axis, then the x, y, z, okay, then here, and you can sketch this. Okay, is a circle. Okay, circle to the x and y for the xy plane, and radius is 4. Okay, but there is a height referring to the z. Okay, once there is a z, okay, the z basically, you are referring to this, and you just pulled up, and the height becomes z equals to 5. Therefore, you can see the cylinder. Okay, in the sketching is this is how you sketch. And sometimes the question will be, if they refer to, you not necessary to sketch complete. Okay, there are 2 ways they will address the problem. They may say it's a octant or quadrant. If they mention this as a octant or quadrant, then immediately you need to sketch that as a octant based cylinder. Okay, octant based cylinders. The means still similar, but the reference is something called r equals to 4. Okay, this is another type of sketching. And once the question is something, the volume based questions, if required, then you should be able to identify the equation. Based on the equation, you should be able to sketch. Other than that, is there any other equations that you supposed to know? There is of course one more, and which is most of the time will be very challenging to sketch. Number 3, number 4. Okay, number 4 is a spherical. Okay, spherical. 25, sometime I put it as a R2, but it's a 5, for example 5. This is a radius. Always remember the radius is a 5 power 2. Okay, then when you sketch in the full scale for the XYZ, for the XYZ, it's a cylindrical. Okay, sorry, spherical. Okay. The next one is a hemispherical or quadrant base. You need to be very careful when if the question addressed to you to sketch only quadrant. Okay, most of the time you can see this as a R or rho I introduced to you as a 5. In this case also the rho is a 5. Okay, the sketch, this is a quadrant base spherical. Okay, this is very fundamental. Suppose the question asks you to sketch, but normally they never ask you to sketch, but the sketch is a part of the question itself. Okay, they never ask you separately to sketch the to sketch, but instead you it's a kind of compulsory to sketch. Okay, it forces you to sketch the problem, the volume before you solve the question. Okay, other than that, the first Gauss theorem in the Gauss definition, the simple definition is this. Let me start define to you what is Gauss definition, and based on that, I skip this one. I don't want to because it's easy, then I can use. Okay, the first Gauss theorem in the Gauss divergent or divergent Gauss theorem or Gauss divergence theorem is a theorem, you know. It means it can be proved. There is a proof for this, and okay, I'll just sketch one based on the cylindrical, okay, cylinders. If for the it can be a spherical, it can be a cubic, whatever, it can be tetra, or it can be a spherical, it can be a cylindrical, no problem, as long as there is a complete closed. See, the first terms that I'm going to introduce to you is for, okay, enclosed. This is very important. Surfaces, okay, enclosed surface S. That means it's a closed. Everywhere, wherever you touch, it must be all closed. It should not be any open kind of surface. There might be a lid here, then it cannot be opened. You know, you need to make sure it's everything closed. Okay, enclosed, or the region V, we call it that is enclosed surfaces S. It can be many surfaces S, maybe one S or many, or region V, I call it that as a region V. Volume in a vector field F. Okay, what they mean by that? Okay, you are throwing something inside called F. The ghost going inside. Let's say the ghost, you are throwing the ghost inside the closed surface. Now the ghost is inside. Now we're going to analyze based on the Gauss divergent theorem. Okay, there are two important these things. One, I call it as a A. Okay, it's a star. I put it here. Okay, it's it's very important because I'm stressing this point. All the surfaces are closed. You need to make sure all the surfaces are closed in order to work with this Gauss divergent theorem. If any one of these surfaces is opened, you cannot use divergent theorem to solve that. Okay, you must remember that this is a very important definition. Okay, number 2B also is another important message here. In a Gauss divergent, only able to evaluating, okay, it will evaluate, okay, evaluate the volume. Okay, it's only evaluate volume. It cannot evaluate one particular single surface. Let's say the question asking you to only find the surface integral, you cannot use Gauss divergent to calculate. Okay, if the question asks something to do with the volume, then you can use Gauss divergent. Remember again, I repeat the same thing again. You cannot calculate any single particular surface using Gauss divergent theorem. Okay, Gauss divergent theorem only can be used to calculate, okay, volume base polygon. Okay, that's a very important. Okay, with that, the definition is something is like this: volume of V, that means it's a 3, is involved here. Del divergent is a dV, volume base. Divergence of, for the volume, okay, volume here, it's equivalent to F dot surface integration, SO, small s, very careful, it's not a big S, because I already introduced N here. Otherwise I can write as a big letter. Okay, or I can go for F dot D, big S. This is a big S. Once I split that, the compound of this is a N ds. Okay, ds compound. Okay, this must be a 2. Okay, once we refer to 2, which is surface base, and this also 2 is a surface base. Okay, and this equation must be not a single any particular equation, it all the surfaces, okay, is a sum of all the surfaces. I forgot, sum, very important, sum of all the surfaces, sum of all the surfaces. Okay, can you see that? Sorry, sum of all the surfaces. We sum all the surfaces is a volume base. That means you cannot single surfaces, and you need to remember, and all the surfaces must be sum of, and it must be closed. I stress this word again, closed. Here also I mentioned this word, closed. Okay, because you're going to learn Stokes theorem. Closed theorem is a slightly different from this. That's why I'm emphasizing this again and again. It must be all the surfaces, sum of, we are taking, and closed. For example, before I proceed further, I give you a simple, before we start any calculation. Over here we can see there is a surfaces, surface 1. Consider this is a surface, the volume in and volume out, divergent in, divergent out, and there is a S2 which is here, in and out, and of course there is a something called volume here, that is a volume that we are referring to the volume here, and this is we call S3, the surface, okay, of cylindrical, okay, whereby the things may go out and come in from this surface as well. Okay, but the logic that we are trying to bring inside here, it can be a volume, can be a negative or positive, it doesn't matter, as long as we are talking whether it's going in and going out. But the logic that most of the time that we are most interested to see is not what is going inside, but what is coming out. Therefore, most of the time in the engineering questions, we are interested to see what is the flow out, okay, the expansion of that particular point. Okay, we want to see more things coming out of this, okay, the flow out. And in total, the calculations that I'm going to introduce to you, when I refer to this one, divergent theorem, the divergent volume to the F to the dV is equivalent to, we are taking F S1, which is F dot N ds, oh you cannot see, sorry, okay, which is calculate here S2 F dot N Fn ds and plus S3 F dot N ds. Okay, and overall calculation, it will produce 6 for this I didn't give you the question yet. How can I can give you the answer? Oh, sorry. Okay. It's not, I wanted to give you a sample only. Later I'll give you the examples of this. Okay, this is an idea. Okay, I just initially I wanted to give you an idea. Okay, how do we calculate and we able to solve the problem of this equation. Okay, this one so far. Okay, then I didn't set the question yet. Okay, let me go to the example. I hope that you already seen. You have basically you have some idea. Okay, now how the Gauss divergent theorem really work. You see, okay, I didn't elaborate this into detail yet. Okay, but you try to see these three calculation. Earlier when we started with the surface integral calculation, we found that is a very extensively long and we need to identify every single surfaces. Okay, every single surfaces we need to calculate one by one, and which required a lot of time for us to calculate. But Gauss divergent theorem helping us to solve this problem easily by giving this solution, which is basically saying, okay, when you calculate every single surface separately, okay, the surface integrations, okay, the combination of all for the volume, a particular volume for the closed system, can be calculated by using divergent volume theorem, which is as a Gauss theorem here. Okay, you may find it this is a very easy method, and you will really enjoy this as well. Okay, you will enjoy this, and you may say, oh wow, this is too good for you to calculate the whole thing in a simple way. Okay, that is the most important thing. It's a simple way. Is there any simple way to calculate this kind of complex problem? Okay, now okay, let me start with some simple things first, then slowly we will go into the complex calculations. Okay, now the first example. Okay, the first example I choose, let me choose to work with the simple model. Okay, simple model. What is the example that I can pick here? Wait, let me see. Okay, I got one example here. I will give you more, okay, within the time that, because this required some examples here. 2I Z J Y K taken on the region bonded, okay, bonded by the planes Z x0 y0 x okay, it's x equals to 1, y equals to 3, equals to 2. Okay, the question is find the divergence. Okay, find the divergence using, of course, divergent theorem. Okay, now first question you will ask to me, sir, I got it, but now the question is straightforward here. They use one word here called find. When they use this word find, there are two type of question they will ask for this particular things. I just highlight this. They may ask find the divergence, or they may ask verify. Okay, verify or prove the divergence. There are two type of questions. Okay, two type of question. Okay, only two type of question they will ask. Okay, pattern. The pattern of questions will be two. Okay, this is number one, this is number two. Okay, they will ask you find the divergence or verify the divergence. Okay, if they ask find the divergence, okay, sorry, maybe I'll start with the second one. Suppose I need to put it on the top. Okay, there will be a two type of question only. Okay, once they ask you to verify the divergent question, this means you need to give a proof. Okay, you need to go for the you need to work on the proving method. Okay, it's a kind of proving method you need to use. That means you need to, here you don't need to prove, you just solve. Okay, you just need to solve. Here you need to prove. Okay, you need to the proof is sometime, you know, it's a kind of, you need to use the proof to verify both whether it's a same or not. In this second, the first method, you can go for, in the first case, you can go for this del v dv, or you can use this option, or you can go for the S1. Sorry, I didn't sketch the problem yet, but I already started working on this. Okay, but you can go for the, okay, as surfaces, all the surfaces, sum of all the surfaces, okay, all the surfaces. Okay, you can either you can go for this or this. But option 2, when they use verify question, you don't have any options. Okay, you need to prove both. Okay, you need to work on the both side. You need to show both. This is very lengthy question. Okay, it will be a very lengthy question. No other way, you need to show this equal. Okay, in this particular case, you choose any one of this, and you can you don't need to prove, you know, you don't need to prove, you don't need to what do you call solve both sides. Instead, you can choose one of this. Here you need to work on this both. Okay, both, and you need to solve and show. You need to show both. Okay, can I say show both as an evidence? As an evidence. This is very important. Okay, the question depends on the question. If this is a verify, okay, this is a verify. Okay, this one is just to find. If the question is find, okay, the things is most important over here is just to prove. You need to verify. Here, just to find. Similarly, it's going to work for the Gauss theorem, Stokes theorem later that you're going to learn. If the question asks you to verify, you need to show both. Okay, if the question asks you to find, you need to choose either one of this, whichever method you can choose. And not necessary again, you need to be smart. If the question asks you find, please don't do both. You are wasting your time. Okay, this is not exam time anyway. Let's say it's an open time question, the time limit is there, then I will say please choose one. If you have enough time, then you can do both, no problem, just to verify to yourself, okay, this is verifiable for the solution, because you can show, okay, both are same. Okay, now let me sketch this problem. Okay, let me sketch this first. This sketching, okay, is a first you need to sketch this. It's could be a cuboid kind of things, and see how it works. Okay, this is again kind of can you see that? Okay, both. See the sketch. Sorry. Okay, done. And say A, B, C, D, E, F, G, H, or too many surfaces, right? Little bit challenging, because if not to say bit challenging in this case, but too many surfaces, right? The surfaces, the job too much to be identified here. This means how many surfaces are there? Okay, we need to list down first. Okay, S1 I save some sign, A, B, C, D. S2 I call it as B. What is it? B, G, H. Okay, B, C, F, G. Okay, S3 C D E F, okay, and S4 A B G H, S5 A D, what is that, A D H A B A D A D, okay, E H, E H, okay, S6 E F G H, okay, altogether there are 6 surfaces. Okay, and therefore when I throw something goes inside here, we wanted to see how the ghosts react inside and how the flow, okay, divergent flow in and out of, the out of the box will react. Okay, it's a flow analysis here, whereby that we can see in a simple, I try to draft the logics of this. Since this question is fine, okay, since it's a fine, imagine, okay, you need to show, let's say verify, no problem, you can do both. In this particular case, okay, you need to do S1, you need to show S2, you need to show S3, okay, S4, S5, S6. See, it's very lengthy, okay, and which can be solved within 1 minute. You can see this one very fast, but it will take long time, okay, because you need to identify every single surfaces of this. Some of these surfaces will combine into one we call Gauss divergent theorem. Now we know why Gauss divergent theorem is good, because it's able to help you to identify the divergence surface integral in a simple way and very fast. Okay, now let me show you one by one, and we start working on the first, which we're going to use this model, you see, and you calculate this, okay, the cuboid of the calculations of this. Okay, can we start? Okay, let me, okay, in this, can you, I hope that I worried sometimes you cannot see certain things when okay, again, this movement of the paper sometimes it's disturbing. Okay, it's not clear. Okay, just because, let me adjust it. Okay, because, okay, done. Okay, then let me start. Okay, we will do the calculation for, when I start move, then it will become blur bit. Okay, it's a camera focus, okay. Now in this case we are going to calculate this del f dot f product to the dot product. We are going to calculate this. Therefore, first we just choose this del divergent. Can we calculate the divergent? What is del dot f? Okay, f is basically when you start seeing the problem, and I hope that you can calculate divergent easily. And the calculation for the divergent is first. Let me show you first one time only. I cannot repeat this work again. Y J is a basic. K. Okay, oh, my a little bit higher. Okay, dot product with this x2 I. Is it x2? What is the question? x2 zj yk. Okay, and since, okay, always this is another issue. Sometimes student, most of the time they confuse with the dot and product. Okay, this is a dot anyway. Okay, we're going to use I, same x, therefore you get a the differentiation of this, you will get a 2x, and this I j 1, therefore here 0, and y d to the dz is a 0. Okay, that means the divergent of this f here is a 2x. Okay, now with that Can we start work on that? Okay, we need to calculate the volume. Remember, this is a volume. Volume means is we need to expand this V, okay, we're going to expand this V, and therefore this will go, the divergence will go inside here, and we're going to calculate this volume. Okay, we're going to calculate the volume of this, okay, the size, length, and which is basically is a dx dy dy dx and dz. Okay, this is by the nature that you able to calculate by this dx dy dz. Okay, now the issue is, since this question is a very straightforward, you no need to worry, because the solution here is very clearly given. X is a highest is a 1, okay, this one is a 1, this is what do you call, the z is a highest point is a 2, and this one is a 3. That means it's a basic things here, which is you can calculate every single point here roughly. Okay, therefore the range is known. You see, I set the range very fast. This is fixed. This is the easiest question anyway. dz is the range is from the higher to the bottom is 2 to 0. Okay, y 3 to 1. What about x 1 0? Wow, this is a fantastic, because it's a very fast we can solve this problem. 2 to 0, 3 to 1, and 1 to 0, 2x dx dy dz, and the solution is a 6. Okay, the solution is 6. Please do try. This is a very not a difficult one. I hope that you can solve by yourself. Okay, I think anybody can solve this practically. Should be able to solve that. Okay, now our next task is to prove the model. Okay, if we wanted to prove, assume the question is verified. Assume the question is verified. Okay, we need to calculate basically del for the surfaces. We're going to calculate this, right? Okay, we're going to calculate for the S1, S2, S3, S4, S5, S6, right? Okay, you need to calculate S1, S2, S3, S4, S5, 6. Okay, we're going to do that very fast. Let us start very fast. Okay, we're going to do that. Okay, first is okay, I divide this very fast, make it a little bit faster. We can solve it by before, I think the battery is always, the battery is an issue here. Okay, let me copy. Okay, this CD is experience. Okay, we wanted to get a S1. Okay, in order to calculate the Fn to the ds for the A, B, C, okay, look at this one first. Okay, it's a repetitions here. A, B, C, D. Okay, what is the surface? The surface arrow is very clear. Can you see that? Okay, it's a pointing to the X. If it is a pointing to the X, okay, then very easy. The S1 n is equals to I. Okay, what is the next important point that you can identify here? Can we get any other information? Yes, the one here, the surface is on the surface called x equals to 1. X equals to 1. Okay, these are two valuable information that we can mix around and we can use. Okay, when we start combine here, f dot with the n product. Okay, what is the f and n? I okay, is basically is a x2 to the I z, okay, j to the yk dot with the I. Of course, you get a x2. Okay, this x2, since we know x equals to 1, then you get an answer is a 1. And what is the surface that we're going to calculate? What is the surface that we're going to calculate for the ds part? You see, this is dy, this is dz, dz. Okay, therefore, here the ds is dy dz. Okay, can we calculate that? Yes, very fast you can calculate. And for surprise, some student will just get shocked. Hey, come on, very fast we get this solution, dy dz. And what is the maximum point here? It's a 2 to the 0, 3 to the 0. Then when you solve this, you get a 6. Wow, in the beginning itself you already got a 6. Then some student may say, wow, if I got a 6 here, okay, remember what is this, ABCD, right? ABCD is a 6. If this is a 6, definitely all this must be 0. Can you guess this? Can I guess this way and say, okay, this is rest of the things is all 0? Cannot. You cannot do